Well, it's been a little over a month since we've had the Scott amp back on the bench. We are back in the saddle. We have the transformer has been returned. It has been rewound. This was from a company called Heyboer, Heyboer. I'll put a link in the description. And Arlen is the fella I communicated with, and for at least at the price of this video was $175 to rewind this transformer. As you might recall from part one of this video, we had a shorted primary winding on this transformer, and so it is now back. I have been checking all of the windings. First, I checked them just with my ohm meter to make sure everything looked good, and you can see kind of the readings that I've gotten there. Nothing was shorted, everything looked good. And then I also checked it by applying power to the primary input and measuring the voltages. And those look very good as well. So the main high voltage output is the center tapped. It's supposed to be about 700 and some volts, and we got about that. The bias voltage checked out, the filaments checked out, and the rectifier voltages all checked out. So that's good. So now it'll be time to put this back, mount the transformer back into the amplifier, and hook it all up and begin the process of hopefully making some beautiful music. The transformer has been remounted. It was a little tricky to shove all these wires through the opening. Now I have to look up in the instructions to figure out what goes where and get these lines all hooked up. And the transformer has now been connected into the circuit. These wires are not the easiest to move around, but we've got everything connected. I have applied power right now through the variac and also through the dim bulb. We're running right now at, what do we got, 60 volts going in, and I've been checking both the AC and DC voltages. There are no tubes installed yet, so I just wanted to verify that we're not shorted out anywhere. The transformer is functioning properly, and yeah, I think we're looking pretty good. I will up the power now to a full 120 volts. We can bypass the dim bulb and put the tubes in here and start checking the rest of the circuits. I now have only the rectifier tube installed, and I want to verify that the B+ voltages are going to look good before I put in any other tubes and test the rest of this out. So at the moment I have my variac set at about 50 volts, 48.7, and we're going to turn it on, and I'm connected on the voltmeter to monitor the B+ voltage. And so we've got the amp turned on, and we're, like I said, we're set at 48 volts on the, we can see the rectifier tube is starting to fire up here. Our B+ is climbing. I'm going to bring the voltage on the variac up. I don't see any smoke, so that's a good thing. Let's bring this up a little over 60. We see our B+ going up. And let's go up all the way towards 117. $97. You can see our B+ is now climbing towards 405. That's good. $110 volt going in, 115 going in, and our B+ is up at 450. Very good. So that all looks good. So we can put in some of these tubes and begin to check our voltages and bias, hook up some speakers, and hopefully make some pretty music. There are several different ways to test this. These are the instructions that were provided with the restoration kit, and I think I'll start with those because as far as I know, this amp did work once upon a time. And so they recommend starting it up on a dim bulb or variac, which I've already done to verify that the transformer is working, and then have the tubes installed except for the output tubes, the 7109s. And so that's what 7189s. So that's what I've done. All the tubes are installed except the 7189. We will turn it up, and then we're measuring the output tube anode voltages, and that's on pin 7 over here. Right now I'm connected to tube V4, was one of the 7189s, and we will turn it up and monitor that voltage, and it should be pretty high. So let's do that. We're connected to our variac. Let's turn on the amp. We have 117 volts going in, and on the voltmeter down there we are measuring that tube voltage. So keep an eye on our current draw, 40 watts. So the first time it's been powered on with all the tubes in there. You can see our B plus voltage is climbing. 400 volts, 422. We're drawing 50 watts, 40 watts. That should be pretty reasonable. So yeah, so that looks good. No smoke, that's also a good sign. Starting to smell the tubes heating up. It's always a nice smell. And so yeah, let's go on to the next step. We were getting 430 some volts on pin 7, and now connected to pin 9 we're getting 428 volts, which is a little lower, which is what the instructions said we should be seeing. Now measuring the grid voltage on pin 2, and it's minus 19 volts, which it's supposed to be, a negative voltage. And I will check the voltage on the other 4 output tubes and verify those. Next, I will use the assembly manual instructions to initially set the balance controls and the bias adjustment. It's an interesting procedure. They have you use a special cable that I guess came with the kit. I just made my own. It's an RCA cable, just one jack, that jumpers one of the speaker outputs to, in this case they're going to use the tuner input, and then it tells you how to set the front panel controls, and we're going to try to listen and adjust the balance pots for minimum hum. I just turned on the amp, and the instructions say to let it warm up for a brief few minutes here, and then we will slowly turn up the volume loudness control until we can hear some hum in the speaker. I have that far speaker over there connected, and then we will adjust P6 to minimize the hum. So let's see how we're doing here. Okay, I can just begin to hear some hum. Not sure if you can hear it on the mic. My screwdriver wasn't working so good on this control because, as I just discovered, it's cracked on one side. So I have adjusted it, I think, for the minimum hum here. It doesn't make a lot of difference, though, to go from one end to the other. So now we have to reverse these connections and do the same thing and adjust this P5 pot. Now I need to adjust P5 for minimum hum. Let me turn it up, see if you can hear the hum or not on the camera. My water heater's making noise over there. This control at least doesn't have its slot broken. Louder, louder. And that seems to be the quietest spot right there. It's a little more noticeable on this side than it was on the other side. So we'll see. And then we will move on to the bias adjustment. Now I'm following the assembly manual instructions for setting the bias. We jump a jumper cable from these bias test point jacks back to the tuner input. So this is for the left side. And then there's a button here, a switch, that you slide back and forth, and you'll hear a click. And as we adjust P8, the click gets quieter. Right there is pretty much gone. So that's supposed to be the optimal adjustment for that side. Now we'll do the same on the other side. Now I switched over to adjust P7. Same idea, flipping this switch. We hear the ticks. We move this control clockwise and the ticks get quieter until they're almost gone. Probably about right there. So that's one way to set the bias. Interesting. I think I've got the bias and balance control set as well as we can do using these procedures, and so let's hear this thing make some music. We are making music. Just streaming from my iTunes library here. Let's crank up the volume a bit. So next I will hook up my scope and a signal generator, and we'll do some measurements and just see how well we're performing, but it sounds great. Now let's test this thing. I've got the setup here. I'm using my iPad as a signal generator. I've got this Audio Tools application that lets me put out various signals at different frequencies. I am feeding the speaker outputs into my 100 watt 8 ohm dummy load. We've got the scope connected to those outputs, and let's crank it up and see what we get. I'm feeding a 1 kilohertz signal into both channels, and let's turn up the volume. And let's see, right now we are getting, this has got a 10 times probe, so we're just starting to clip at, let's call that 35 volts peak to peak. Yeah, 34, 35 volts peak to peak. Let's do a little bit of math. So that works out to about 20 watts per channel, which is probably correct. Now let's try this at, let's say 10 kilohertz. And we will need to change our scope a little bit here. 10 kilohertz. You can can just see it starting to, some crossover distortion there at the midline, kicking in at about 30 volts. And now at 20 hertz, we are also maxing out at about 31 volts at 20 hertz. So that's also going to be about 15 watts per channel. So let's kind of do the same thing and check the frequency response at those levels with a fixed output where we're not driving the amp quite so hard. Until now, it's running a sweep from 20 hertz up to 20 kilohertz, and if we just watch the amplitude on the scope, you'll see it's pretty flat. Yeah, it really doesn't vary much at all. It looks quite good. You can actually hear the sweep a little bit in the output transformers there too. Yeah, I like that. This thing is performing very, very nicely for a 60-year-old amplifier. Square wave responses are always interesting to look at. So this is a 1 kilohertz square wave, and if you look at the ringing, that's at about 20 kilohertz. Again, you know, for an amp like this, I think that's pretty good transient response. The bottom cover has been reattached. It was missing the feet, so I found some that seem like they'll work fine. And now we'll just do a few more final tests and listen to it, and I think we'll be good to send this baby home. The amp is pretty much buttoned up now. There is no overall cover. I know the original owner is going to be looking for one of those. So now I just want to verify all of the inputs are working, all of the front panel controls are working. I have a 1 kilohertz sine wave feeding in right now to the tuner input, and we are selected on the tuner input. And as I turn up the volume, we see that that is working just fine. And so now let's take a look at some of the tone controls. So let me go to a 100 hertz signal, and we'll adjust the bass control down and the bass control up, and that is working. And then we'll do the same for treble. Let's go to a 10 kilohertz signal, and we will adjust the treble down and the treble up, and we see that that is working. So that's all good. There's also a loudness compensator switch on the front. That's mostly going to impact lower frequencies. So let's go back to our 100 hertz signal and flip that on, and we see the bass goes up a bit, and that's what we'd expect to see. I don't know if it's going to impact the higher frequencies very much. A little bit, not much. The tone controls obviously do more. Okay, let's switch to the extra input and make sure that that is working. Now we're hooked up on the extra input, and that is also working just fine. I'm just increasing the volume up and down here, so that looks good. Let's check out the tape input. Now we're connected on the tape input on the back, and we'll note there's a switch on the front for tape in and out. So I've switched that to tape in, and that's working. If I go tape out, that signal goes away, back to tape in. So that is working just fine. Now let's check the phono inputs. For the phono input, we would set the front panel selector to phono, and then we also have to pick the equalization, and that needs to be in the RIAA phono position. The NAB tape only applies to the tape input on the back, and so we are now connected there. The ceramic input will be a higher level input for a ceramic cartridge, so I've still got my 1 volt peak-to-peak signal going in, and now we'll switch to the lower level magnetic phono cartridge input and take a look at that. The magnetic input is expecting a much lower level signal, so in fact you'll see my 1 volt peak-to-peak is overdriving that circuit, so I've got to bring my level down on my input, and then that looks much better. That looks much better. The other thing we can kind of see is the effect of the equalization here. So I'm on the RIAA phono position, and if I change the frequency, that's 1 kilohertz. If I go down to 100 hertz, you'll see the level gets much bigger at 100 hertz, and at 10 kilohertz it's smaller, and that's the way the RIAA equalization curve works. So that looks good. And now let's check the other inputs here. And now we're connected to the other magnetic cartridge input. There's two, one high and low. So depending on the output of the phono cartridge, you would pick the appropriate one. And again, it's pretty easy to overdrive this one. If I crank up the signal going in, you'll see it distorts pretty quick. And this is now a pretty low level signal that I'm feeding in. And then finally, there's this NAB tape input. Not exactly sure when one would use that. I don't think tape decks today would necessarily need that. But then you have to flip this front panel switch to the NAB position instead of RIAA, and this is also expecting a pretty low level signal. I can see I'm already kind of overdriving it here. So yeah, so I think all of the inputs on the front are working just fine. All of the switches seem to be working just fine, and let's hear some music now. One switch I almost forgot to check, and that's the scratch switch. So right now I just have a 10 kilohertz signal going in, and basically this is just a high cut. When I flip that in, you'll see the high frequencies come down just a little bit. So that also works. So yeah, let's play some music now. Well, this has been a really fun project. Took a while. I didn't realize that transformer was going to be defective, but it sounds great. It tests out great. So yeah, let's listen to a little bit of music here. Turn it up a bit. So I hope you've enjoyed this video, and maybe someone out there will find this useful. Be happy to have you subscribe to my channel, give it a like, thumbs up, all that good stuff, and we'll be back with some more videos on some other topics.